The science of mouthguards is fairly complicated, but for this presentation has been simplified into two key areas: absorbing the force and spreading the force. Absorbing the force. Let's do an experiment. Take an egg, drop it onto a solid surface. Surprise, surprise, it breaks. Now, put some foam on the solid surface and repeat the exercise. And no omelette tonight. The egg's fine. But why? In experiment 1, the egg decelerates from full speed to full stop in a minute fraction of a second. In experiment 2, the egg comes to a stop more gradually. So from Newton's laws of physics, we've learnt that F equals ma, force equals mass times acceleration. Doubling the time for an object to come to a halt halves the acceleration, which in turn halves the force. So how does OPRO use this? Well, we know that the more gradually we can slow an incoming blow, the greater the reduction in force and therefore damage. So OPRO have spent considerable time working with materials to give us the best properties for typical facial blows. We use multiple materials. The outer shell, for example, is itself a mixture of materials, but as a whole is aimed to absorb the initial high-speed impact. The fins are another unique blend that work to decelerate the already reduced force at an even slower rate. Sophisticated, very effective. The platinum is even more complex, with different blends in different areas to recognise the fact that a blow to the front of the face is different from a blow to the lower jaw, driving the lower teeth upwards. Spreading the force. Here is an egg again, and this time I've given it a little base so it doesn't roll away. I drop a heavy ball on it, and yes, it breaks. Now, I've made this little device. It's hard, it gives no cushioning, but it sits on the side of the egg so that any force I apply is spread across the whole surface on which it comes into contact. I drop the ball, and once again, no omelette tonight. But why? This time the deceleration in experiments 1 or 2 are identical. There's nothing to absorb the force and reduce it. The difference is that while the force is the same, this time it is shared over a larger area, and the force experienced by each part of the egg is small, instead of one large force at the impact point, as in experiment 1. Even though the total force is the same, doubling the area halves the force on each point. So, how does OPRO use this? Simple. We try to ensure that our mouthguards come into contact with as large an area as possible to snugly fit on the teeth and between the teeth. The greater the area of contact, the better the force is distributed and thus diluted. This is the job of our OPRO fins, arguably the most significant invention in the development of mouthguards over the last few decades. They mould around the teeth, giving as wide a coverage as possible. Being there. Now, there is a third quality that a mouthguard requires, which should be mentioned, as without this one, the first two are quite irrelevant. It's that a mouthguard needs to be in the right place when a blow comes. As if it's fallen out completely, or it's moved out of position, well, it won't be much use. OPRO shields are designed with their OPRO fins to be as retentive as possible, so they are there, in place, when most needed. Finally, wherever I've mentioned force, I should stress that the force in question could be about to break a tooth, fracture a jaw, or cause concussion. The bottom line is that by reducing the force as best as we can, your OPRO is designed to lessen any chance of injury.